Howdy, PJ Tech here, and today I have a doozy for you. This was my MIPS recursion project that I did uh, for my junior year during computer organization. Um, so just looking at this brings back a lot of memories, and when I say a lot of memories, a lot, and they were memories not of joy, of pain, of suffering, like the amount of effort and time spent into this project was just unbelievable. Um, for those of you that don't know, assembly language is one step below, regular programming languages like Python, C++, or or Java, those type of languages. Assembly language is one step below that. And so, just when you look at this, you're talking about add I instructions or jump instructions or go to instructions. Like really, you have to worry about registers. You have to worry about memory. That all of that has to be taken care of. We don't get the comfort that we do with programming languages. And so we had to do in our computer organization class. We had to do projects built on or do a project with this, and it's a recursion project in and of itself. And so for this project, um, what we had to do was convert numbers into base 10 and spit out the output. And we had to use recursion in that way. So, for example, if I enter 150, or if I enter 50 in here, I should get 165. Because if I bring up my notepad, I get 165 because if I do 5 times 165 to the first power plus 0 times 165 to the 0th power. I'm sorry, not 165, 33. 33. This turns to 1. Anything up to the 0 power is a 1. So this turns to 0, and this turns to 165. And so that's how that works. So you add, so you're basically doing a decimal conversion, but you do that with the base 33. And so with that, you had to spit out basically a working, um, a base 10 representation of base 33 or whatever your base assigned to you was. And so, first of all, when he said this, right, when the professor was telling us the instructions of this, it took me, I didn't know what to do. I had no idea where to even begin, where to start. I'm like, where do I even go with this? What do I even do? And so it took me 3 days. I went to office hours each time to try to get an idea of how to do this. And I even asked a Stack Overflow answer, or a Stack Overflow question. I even said, I don't want to cheat. Let me see if I can bring that up actually. Um, Stack Overflow. Let's see. That's my username. What was that question? Am I signed in on Stack Overflow? Can I see the status? I'm not. But anyway, I even asked a question on Stack Overflow about it. So it was just, it was one of those things where it was something that was rocking my brain. And so I think it's funny how in, engineering and computer science, you start, I didn't even know these concepts of breaking problems down or debugging or multiple iterations, but or checking the answer as you go. But it was something that I just did naturally. Like it was something I fell into. And so as you can see, I created, basically in my notes, I had, okay, these are the steps that I'm going to do to actually do this problem. Like, where do I even start? And so, I said, first of all, preliminary step, check tab spaces and valid characters because we can have inputs. And let me actually bring back that notepad because we can have inputs. similar to this, right? The strings are not included in the input, but we can have inputs like this, right? And that's a valid input, right? And we would want to get the base centered representation of this. Um, well, are there letters? I believe. Were there letters available? I believe so. I'm not sure. But anyway, we'll check that when we run it. Um, because the code still does work. The code still does work. Um, but that was the preliminary step, and then the first step is recursively call each character in our string. So I'm calling it C. So I'm using mathematical notations with this. No, this is something that I really thought about and I really thought hard about, even though it's only 10 steps, right? So then recursively call each character C. Convert C into its decimal representation. If C does not need to be multiplied, go to step 8. If C does, multiply by D, multiply D by base 33. So D is the decimal representation. And then we store that multiplication in temporary answer. Excuse me, in temporary answer, which will be our new D. Then we check and multiply again by 33. Then go to step 4. If not, add to temp answer, and then you're done. So again, it sounds simple. It sounds so easy, but it I mean, when you look at the code, it was 500, I think over almost 700 lines of code that had to be written. So if you just look at it, let's zoom in a little bit here. Again, this is the data, so this is kind of the storage that you're allocating. You have to set that up front. So this is the storage that I'm going to allocate. Um, for our strings, for the space, you know. Here again, you can see the comments. So the comments are really helpful for assembly language. Like it's almost necessary. Well, it's pretty much you have to have comments. I mean, to understand. So each line almost gets a comment, right? So this is where we init carry for final addition. This is where we load address for base number. Get three, and even though you probably can't understand where my line of thinking is, based on what the problem is, and based on what I'm trying to do, based on these steps that I had, based on these 10 steps that I had, if you look at the code for long enough, I'm sure you could kind of figure out what things are doing, right? You could kind of figure that out, right? This is tab space management, so this is removing the leading spaces and tabs. That's the code for tab is 9, so we add that, and then we're I forgot what the if it's equal to that, because this is looping is something that was really a maneuver that you had to learn, and so there's different type of maneuvers that you had to learn in assembly language. So looping was one of them that we used here. So if character is not a leading space or tab, begin a store into string. So we store here, load string in, we need a copy of the beginning space again. So it's just so much, here. Um, and I'm not going to go through everything, but it's one of those things where it really was an ordeal. Like this took a while of trial and error. Again, this was not done in all one night. I did one part, you know, first. The first thing I did was okay. Tabs and space management. Let me just see if I can remove the tabs. And then I'll check that answer. Can I remove the tabs? Yes, I can. So then I move on. And I build up in that way. Like I did not do this in one day. So we're about 9 minutes into this. So let's run it. Let's see. So this is a mock MIPS spin kind of executor here. And I just downloaded the file and let's run it. So I'm going to run it. We could just put it here at the execution speed. I'll play it and I'll just say, let's just say, so 50, right? We did 50 here. Let's say 50 here. Okay. And as you see, we did get the invalid input, so errors are working as well. But let's reset it and let's play it and let's do 50. So we should get 150 or one. I believe. What should we get? 165. Sorry. So it's doing all the calculations here, and you can step through this as well to see exactly the data and what's happening. But let's see if we can break it up. 165. So it works, and we could test it. I mean, we can keep going with this. 237. We get that. Does it handle letters too? It does handle letters, so that's pretty cool. But yeah, I mean, I just wanted to share this project with you guys, and just say that um, this was a very difficult project, but it taught me a lot of things. It taught me number one, how to break problems down into chunks. How to get to this. This was something that I did first before any coding, before anything. This was something that I did, and that's something where I want to take now. This is something that I want to implement now that I'm graduated and started working now. That it's worth it to break problems down into chunks with speed, right? You don't want to spend all day trying to break each problem down to the minimalist thing you could do. But again, 10 steps. That's all. That's I didn't break it down, any more than that. Just 10 steps, and that allowed me to kind of say, okay. That allowed me to kind of process things in a fashion. Um, Again, debugging. Doing one thing at a time. Keep making sure this part works, then this next part, then this next part. Taking my time in each section. I think that's very important. And the second thing is time. I think um, obviously we want to go fast. We want to be able to come up with solutions and quick iterations to deliver. But we also want to understand that, and what this is something that I'm understanding, that it's worth it to do this, right? To break it down, because coding should be. What I'm finding out is coding is easier when we're organized, right? I would not have been able to get to this if I had to just do this straight out, right? If I just had to code all this up. But it worked when I focused just on, for example, this part right here. Just getting it to this part. Can I do this with this part? So, again, this is something that I'm really proud of. As you can see, like, this makes me really smile that I actually completed this and got it to work pretty effectively well, and I got a really good grade on this assignment. So, um, yeah, thanks for watching, and I'll catch you later.